Let's review the scientific method a little bit here. In the front of my classroom, I have a series of posters which are shown here on this screen, and they go through the process of the scientific method. First, we begin by making observations. We observe things in the world around us. Observations are facts in science. They are things that we can all agree on, and they're about the natural world. Those observations can then lead us to asking questions. Why is that happening? What is that? Things like that. Once we have a question, then we do some background research. We try to find out, what do people already know on this? It's almost impossible to ask anything about the natural world that nobody has ever studied, so you'll almost certainly find information about your topic. Usually you can find the answer, somebody has already studied it, but sometimes nobody knows the exact answer to your exact question, and then you have to do some sort of scientific investigation to find the answer. In that case, your background research can help you develop a hypothesis. In this case, the hypothesis symbol that I use in my poster is a bunch of weather symbols, because predicting the weather is a scientific prediction or hypothesis. They're saying that based on the evidence, based on what they can see in temperature, humidity, wind, all that kind of stuff, they're making a prediction or a hypothesis about what the weather will be like. Once you have your hypothesis, you can design and conduct your experiment. And while you're doing your experiment, you're also collecting data, which then leads to collecting and analyzing the data. So I have that little funnel there because all the data is being funneled together to be processed. Once you have your data and your results, you can then make a conclusion. Now I use the fork in the road symbol, or that Y road symbol, for conclusion, because your conclusion is always going to be one of two things. There are two directions you can go. Either your hypothesis was supported, it seems to be true, or your hypothesis was not supported. So the conclusion is always going to tie back to your hypothesis. Now you might remember, we're not proving anything. We're not proving the hypothesis is true. We're just saying our evidence supports the hypothesis. It seems to be true. But there's always a possibility in the future we'll have new information that shows we were wrong, or that maybe the hypothesis is not always true in every case. Finally, the last part is communicating your results. Scientists always communicate their results, writing or speaking at giving presentations, things like that. But it's important scientists share their information so that people around the world can learn and continue doing more research and learning more things. Now let's look a little more closely at designing and conducting your investigation. We need to understand variables. Now variables are things that can change. To vary, V-A-R-Y, means to change. So variables are things that can change. Same thing in math. When x or y is a variable, it's because x might be 5, it might be 7. What x is can change. So variables are things that can change. So we have three types of variables: the independent variable, the dependent variable, and controlled variables. Now the independent variable, that is what the scientist purposely changes in the investigation to see if the dependent variable changes with it. You can also think of it as the difference between your groups. In the case of our tennis ball experiment earlier in the year, what we changed was the grouping from a class of boys and girls to one group of boys, one group of girls. So the independent variable was the gender of the people in the group. That was the difference in our groups. The dependent variable is what is observed and measured during the investigation to see if it changes with the independent variable. In our tennis ball experiment, that was the average number of baskets scored by the people in the groups. So we wanted to see, does the number of baskets depend on whether the group is boys or girls? The independent is called independent because it is separate. It does not depend on it. Whether the group is boys or girls does not depend on the points. But we wanted to see, does the points depend on whether the group is boys or girls? Finally, controlled variables. Those are all the things that could change, but we're going to keep them the same so they don't interfere. For example, everybody stood the same distance from the basket, everybody had the same tennis balls, same number of tries in the same room. Lots of different things were the same, because if we gave boys farther away or closer or anything like that, it could change the results, and then we would not know if boys did better because they had an easier distance to throw, or if they just in fact have better hand-eye coordination for throwing a ball toward a target. In an experiment, it is very important that there is only one independent variable, because that's the thing we're changing. If we have more than one, then that's like having no control variables, because there are too many things changing, we don't know what's causing the results. So only one independent variable. It is possible to have more than one dependent variable. So, for example, in our tennis ball experiment, we just looked at the number of points on average scored, but we could have looked to see, do boys tend to do better on their last shot than just the girls, or all sorts of things we could have looked at. And we just looked at one thing there. But one independent variable all the time. Dependent variable could be more than one. And controlled variables, everything else. Trying to keep everything else the same as much as possible.